Okay, 40th students, let's take a look at where we're going to pick up today with our collections example. So, first of all, I did update the little picture that I was showing you guys yesterday. Oops, let me just bring it over and make it big. So this is the same picture I showed you yesterday, but now you can see here, our linked list class has a ton of methods in it now. This is our method list, right? From the constructor to the different versions of add to we made some get methods and things like that. We're really building up a ton of methods here. And we're not done. We're going to add more and more to this class, which is, in a way, is a good thing. Because methods are actions, right? So we're building a linked list that can do more and more and more by adding methods. And like I said, this is a practical programming thing for you guys. So the more things we give it to do, the better it is for you guys and the less work it'll be in the long run. Okay, I also want to point out that this stuff I'm doing is also available in NetBeans Code Navigator. You may remember this thing called the Navigator, which shows up on this side. Look at what it does. It shows you your methods, and it almost writes them almost in the style of a UML diagram. Notice it's very much like the way I just wrote it. Though it has a few other little cute things in here, like these little up arrows and stuff like that. And it includes your properties down here, and it changes up the icon. Notice the little key icon there? Why is it putting that on get first node? Why do you think, Peter? Because it's protected, yeah. But notice this one with a lock on it. Why has head got a lock on it down here? Because it's private, right. So right in there, it's giving you a little clue on it. Notice that constructor uses a special diamond up here. It's just some nice little clues that's given to you by NetBeans, like most IDEs, to help kind of help you along the way as you're writing your code here. Okay. Now, one of the methods that I think is doing a lot of the work in all the stuff we did yesterday, where yesterday we did get and we did set and stuff like that. Both of these make use of the method GetNote, which is one we wrote a couple classes ago, GetNote. So does front and back, uses get, which uses GetNote. Okay? And I tried to really explain that one to you, but I think I forgot that there is actually a cheesy animation I made in the notes, in the slide notes, right here on GetNote. So GetNotes is in the slide notes, and it has a couple points. This protected method is used internally to get a reference to a node based on an index number. It makes a temporary node called current. There it is right there. And it loops current by advancing it by going current equals current.next. So the animation here shows that current starts at the head, but then it says current equals current head dot next, which moves it along to the next node. And then it says again, current equals current dot next, moves it to the next node. So that's what that code is doing until it reaches its desired location. And that's an important piece. Like this method GetNote does so much of the work that we needed it to do when we were looping through and getting spots and setting spots. So the get and set was part of that. Okay. Today, I want to write our first deletion method or removal method. So I'm going to find a spot here amongst the public methods. Maybe I'll go right here after back. And I'm going to write our first deletion method. It'll be public. And it's going to remove the front of the list. Here's what I'm going to do, though. I'm not going to make it a void method again. Instead, I'm going to make it a method of type T. Remove the front. Doesn't need a parameter, because I know what I'm removing, the front of this list. Why am I returning data type T? Could make it void. I could make it a Boolean method that says true or false, it removed it. So if I'm returning T, what am I removing? Or sorry, what am I returning? Yeah, well, the actual data that's right at the front of the list. So I'm going to remove that. Now, you might think, well, this is easy. I just go right to the head and do that. But we're actually removing it from the list. We're not just returning it, like get the front. We're removing it. And in removing a node, there are 3 situations to consider. One is the typical situation, where we have a big linked list, like say this one. And this, let's say this goes on forever, like a whole bunch of nodes. eventually terminates, and then it backtracks like this. This is a null. This is the head. Okay? So if we think about what's going to happen in this scenario, we're going to be shifting head over to here and getting rid of that first node at the front. We're going to get this thing to be gone. That's what would happen in that scenario. But what would be the other two scenarios? So if that's our first scenario, what would be the other two? Well, what if our list only has one node? It only has one node. That might look a little different, and then maybe that was your clue to the third scenario. What if it's an empty list? What do we do? Okay? So that's what we're going to write the scenarios for. What if it's an empty list? What if our list only has one node? Or what if it has lots of nodes? And we're going to go in reverse order. We're going to go 3, 2, 1 in the way we write this code. Everybody ready? Let's begin. So if it's empty, which we can write basically like that, we have to return something. What should we return? Null. Yeah, let's return a null. There's nothing to delete here, so let's just return a null. If it's an empty list, I can't remove your node for you, but let me get out of here and say, you know what, here's a null. There's nothing for me to remove. Okay, now we're going to pull up an else. Okay. And you might have thought it was an else if, but I'm actually going to make a bigger else section here, because I'm going to hold on to the data first. So I'm going to do this. I'm going to say t data equals cast into data type t data dot. Actually, what I can do is just get the first node, like that. But this also still needs to be cast to data type t. So I get the first node. And by the way, I could have done this several ways. This is one way. I could have said head.data. I could have said get spot 0. I could have used our method called front. We had lots of different ways to get at the first node. That's one of them. So now I have the data. And at the end of this else, I better return that data, because that's what I said I would do, return the data. But now I got to deal with scenario 2 and 3. What if it's a one-node list? Well, how can I know that? Well, if the length of this thing equals 1, well, if the length equals 1, and I'm just about to return the data, what should I do with the list? Yeah, let's wipe it out. And we already have a method to do that called finalize. So let's wipe out the rest of the list. If the length is 1, I'm just going to wipe out the list right there. And then I pull in my else statement. The else now means this is not a one-node list. This is a multiple node list. But we've already dealt with the other scenarios. If it's an empty list, I return a null. If it's not empty, but it's only one node, I wipe out the rest of the list after temporarily grabbing the first node and returning it. Now, for everything else that I'm going to do in here, I've already got the first node, and I'm already going to return it. So I don't have to worry about that anymore. What I have to do inside else here is change the way those references go. So let me draw out the list, and let's see if we can do it together. So let's say this is our first node. And remember, these two pieces are called previous. Sorry, that's not called previous. That's called next. This is called previous. And this is my data. The data honestly doesn't matter. We've already dealt with the data. Next is making a reference to other parts of this list, right? So this is the previous here, and it's next. And it can keep going. It doesn't matter what's going on there, because we're only dealing with the front. This thing here is linked to null right now, right? And this is the head. This is what we're given. We've already taken care of the data. Oh, and this here is linking back to here. Let's think about what we need to do to remove this particular node. We're going to have to shift this over to here. Okay? So that's one thing we got to do, is shift that thing over to there. Let's put it back for now. Is that all that's going to have to happen? We've got 2 links here. We've got to cut those links. So this thing here is going to have to be cut. That's the second thing we're going to need to do. And this thing's going to have to be cut. That's the third thing we need to do. And when I say cut, how do we cut a link? What do? Set it to null. Right. So not necessarily in this order. Those are the 3 things that are going to need to happen. Sever a link, and move head over to there.
How about 2, 3, 1? That's the order of things.
Okay. Why did you put 1 last?
Because I was going to use the head reference in order to jump between.
Yeah. That's a good point. But if I do that last, if I cut these 2 things, how do I get over there? It's like cutting my bridge to this little island over here.
Oh, good point. Yes.
So I got to keep a bridge alive for that to happen.
Okay, so you cut
What if I cut 3? Can I still get back over here? Okay, so if I cut 3, this thing, number 3, if I do that first, then I can bring this over here. Whoa, that's not what's supposed to happen. Oh, man. This is some silly stuff here, grouping stuff here. Okay, forget it. I'm going to show you the code. So the first thing we're going to do is say head equals head dot next. So I'm actually going to jump over to the next one first. So actually that was the first thing I'm doing. I'm going to jump over to the next node. Then here comes a weird line of code. Head dot previous dot next. This is called a double reference. Like a double rainbow. It's a beautiful thing. Head dot previous dot next. I apologize that I have to redraw this. Okay, this is head, and I just moved it over to its next, right? This is next right there. When I say, watch me track this, head dot previous, I jumped along the red line, dot next, I'm talking about this green line right here. And I just said, set this to null. So I just did that with that line of code. So this is what our list looks like now. What's the last line we need to do? Yeah, correct. Head dot previous equals null. That's the next line we say. Head dot previous equals null. And by the way, there are other ways you can write this code, but what that did is what I'm going to do right now. This arrow doesn't exist anymore. Instead, we just put a null pointer right there. And now notice that thing. It's like a little island we just sent flying off into the middle of nowhere. Hang on. There's one other thing we need to do. Nope. We need to adjust our length. The length of this list needs to go down. At this point, we're good. That will perform what we needed it to perform. Liam. Good question. Is the node still in memory? In modern languages like Java and C#, they have built into them something called automatic garbage collection. And what automatic garbage collection does is it automatically looks for memory that is not referenced by anything. Okay? And when it notices that it has this node thing that has no name and no references, it gets rid of it. This is in the slide notes too. References are redirected into including a double reference. But it then says, a call to the system's garbage collector will free up unreferenced memory. So what happens is eventually it gets rid of it. But if you don't want to wait, we can actually write a line of code to automatically get the garbage collector going. It's like here if you have garbage and you don't want to wait till garbage day and you say, garbage collector, come now, you can write this line, system.gc, which will automatically collect the garbage. Let's put that into our code after length minus minus. System dot, and by the way, I'm just going to pause for a second and show you the documentation right here. This is what Java says. Calling the GC, garbage collector, that's what the cool kids call it, means that Java virtual machine will expend an effort towards recycling unused objects in order to make the memory they currently occupy available for quick reuse. So this is more efficient than, say, the arrays because it's digging right in and making the computer get rid of that memory. And we talked about that, how this is a more efficient system of memory than something like the array. When control returns, it will do its best effort to reclaim space from all discarded objects. Okay? So it is doing what we want it to do in the sense that it will automatically get rid of the garbage there. That line is optional though. It will do what we said right here eventually, but by putting this line in, it's having it do it right now. Okay, let's put this to the test. Let's see if we can get rid of, so we just outputted the copy right here, right? That was the last line we wrote yesterday. So how about this? Copy dot remove the front. And by the way, when it does that, it returns it. So let's pick up what it returns. A string of garbage equals remove the front. Let's S out the garbage. Whoa, caps lock. And then let's S out the list or the copy. So what I've done here is I said, you know what? Remove the front of this thing and hang on to it, what you just removed. Spit it out so I can see that you removed it properly, and then show me the list now after it's been removed. And if all goes right in the universe, we crash. Well, let's see. This line crashed it. Why?
Because you're calling the garbage collector, which is deleting the node because you're referencing the node.
Maybe. What does it say is the error here? Anyone notice?
Class exception.
It says node cannot be cast to string.
Because you have to put
So it's saying it's returning here.
garbage.data. Because you're outputting the node.
I'm outputting the data, which gets the first node. That's right. So what we need to do is get the data out of that node. So instead of up here putting get first node, why don't we do this? Head.data. That's a little bit better. So we take the data right out of the head up here. Let's see if that fixes it. Kitten. And notice the list has kitten gone now. So we did it. I wanted that error in there so that not that just, and honestly, I didn't plan it. I'll be honest with you. I didn't plan it. But I'm glad the errors do come up when programming because I want you guys to see that you shouldn't skip over this all the time. You shouldn't skip over the error just and not read it. Read that it says it's a cast exception. And that often is the clue that helps you to unravel where the error is taking place. And also clicking on these lines can sometimes help as well to say, well, which line is causing the crash? Oh, it's this line. So somehow remove front, and then you can keep going in and figuring out exactly where the error is taking place. Okay? I think that's super important. And that is where we'll end today. So I will end this video by saying, and I would like a new adverb and a new adjective right now, kids. So new adverb first, and the adjective.
Like, or no adjective. Thick. MF. Moist. MF. Moist. MF. Moist. MF.
No.
Thick with two gotta say moist.
All right, I'm doing it, but it's super creepy. What was the adverb again? Or sorry, was the verb?
Destroy.
So everyone, please destroy that moist subscribe button.